Good morning, ladies and gentlemen. So, I'm Harish Damboli, coming from Reliance Industries India, at one of the petrochemical manufacturing site as a instrumentation reliability head. See, I'll give you just a brief introduction to my company. Our Dhirubhai Ambani is a person, he is a founder chairman. He started his journey of Reliance in 1948. He was at the gas station clerk at Aden. And beside that Aden, there was a refinery. He dreamed about that refinery to owning the bigger size than that refinery. In 1956, he was there in the general marketing manager, Burma Shell Products. 1957, he established the Reliance Commercial Corporation in India, exports spices and he imports polyesters. 1966, established Reliance Industries textile mills in Naroda in the western part of India. 1968, again it's a Vimal Textiles brand launched in India. 1977, he came out with the public share offering, oversubscribed by 7 times. 1982, he built up the fiber and filament plant in Patalganga near Mumbai. 1999, he completes the Jamnagar refinery, and so on, backward integrated from consumer to wellhead. India's largest private sector enterprise, fiscal 12-13, financial performance highlights. Revenue is 68.4 billion and PBDIT is 7.1. Net profit 3.9 billion. Exports 44.1 billion. Rank 107 in Fortune 500 list. Strong balance sheet and liquidity, debt free on a net basis. Best in class refining, top decile performance in refining through the cycle. 2 of the world's largest and most complex refinery at a single location. Crude processing capacity 1.24 million barrels per day. Combined Nelson complexity index more than 12. You can see the graph. Infrastructure advantage, access to global crude and product markets. Operating cost per barrel among the lowest in the world. Among world's leading producer ultra clean fuels. Leaders position in the petrochemicals, largest refining capacity at a single location, largest producer of the polyester fiber yarn, 5th largest producer of the paraxylene, 5th largest producer of the propylene, 8th largest producer of the MEG, monoethylene glycol, and 9th largest producer of the PTA. It's a raw material for the yarn. We have the manufacturing sites at the 6 location in the western part of country. We had undergone the backward integration from textile to crude. See, this started with the textiles, Vimal, Harmony, furnishing fabrics, Slumbells, Recrons. Raw material for these was again added with the fiber chemicals. So these are the raw materials for the manufacturing of the textiles, and so on. Raw material for these fibers is polymer and fiber chemicals and oil and gas. So this is what the backward integration we have undergone. This is the site where I am the instrumentation reliability head. It's a different plants, getting the different feedstock from the different oil and gas and the products. Now coming to the application where we have done some value addition as far as the smart device in the field is concerned. Application in the particularly in the compressor, the oxygen and nitrogen compressor we had in the plant to compress the oxygen at a higher pressure for the process application, say for example ethylene oxide reactor. function of the particular device was the safety interlock, and there are the high alarms and the very high trip for the compressor stoppage. It's a very narrow deadband as far as the alarms and trip set points are concerned. It is particularly talking about 184 degrees centigrade and 187 degrees centigrade. It's hardly 2 or 3 degrees centigrade. So, first installation we had done in 2007 in one of the turnaround. Total units till date we had installed, replaced the normal conventional switches, pressures and temperature switches by the smart switches. And importance of this device, each failure and false trip result into the reduction of the 50% throughput of the plant. Now, problem statement is that we had blind electromechanical temperature pressure switches. Disadvantage or whatever you say, drawbacks: no process parameter indication or the diagnostic of the mechanical switches. We have this application is on the compressor, it's a reciprocating compressors, and it has its own inherent vibrations which results into the drifting of the set points of the mechanical type of switches, electromechanical type of switches. So, if you want to switching in the short intervals, it is difficult. There are mechanical moving parts including the micro switch and prone to wear due to mechanical movement, difficult to calibrate to configure the switch in short time. Now, what is used is set point drift required routine recalibration and the deadband setting of any of the electromechanical, either it's a temperature switch or the pressure switch. Drift in set points because of the any of the external vibrations or other things will lead into the spurious trip and plant shutdown, resulting into the production loss. Again, the technician or the engineer has to rush to the plant. It's a unnecessary, unwanted visit to the plant. Frequent calibration to maintain the performance, to assure the performance of the interlock, and it consumes time for the calibration even, because we need to bypass a particular parameter, keeping in a view that what others are backup for the particular parameter which we are going to bypass. So, we have to bypass it, remove it, take it to the lab set, again test it and reinstall it. That is what the problem. Difficult to change the set points in the application with changing conditions. We have some applications where maybe 6 hours I want to run my machine for a particular set pressure, again 4 hours for the other set pressure. Now, by electromechanical switches, it is very difficult to change over the set points in field itself. Either you have to take the pressure pump into the field, do the calibration, it takes a hell of a time. So, two alternatives were considered. It's a traditional safety system with the transmitters, and then do the whatever changes you want to do in the logic solver. Another one is electric controls, one series self-contained digital transmitter switch with embedded logic solver and the final element. These were the challenges. Resolve premature failure. We had as it was at one of the bad actor which was supposed to be addressed. Again, upgrade the reliability of the safety systems. You know, the revealed failure and unrevealed failure. Revealed failures may be accepted, unrevealed failures are not at all acceptable. It creates a disaster if the machine does not trip on the required set point. Withstand very high vibration. reduce false trip, provide one device with a suitable dual outputs for alarms and trip, capable of very narrow deadband, implement in quick shutdown and turnaround, very quick. There is the traditional safety system which has the analog input safety PLCs, require new analog IOs if you want to replace them. So, it is a traditional thing, the temperature transmitter connected to your logic solver with the analog input. Now, with this switch, no change of the logic solvers, any setup into the system which is running, only remove the electromechanical and put it the particular smart device. Reuse discrete IO, relay logic, including the field thermobell, which significantly reduce the total overall cost. So, what was the result? The replacement result into the reduce labor by 50%, reduce commissioning time by 75%. It was calculated based on the total micro activity involved in executing the system. Reduce logic programming to 0, no change in the logic. Reduce rewiring by 100%, same cables are being terminated. Implementing a traditional system would increase cost equivalent to 5 times to changing to the different components of the system, including the field devices. So, these are the uncommon benefits proven in use, already running successfully without any trouble. 2-wire plug and play. It has a very good diagnostic, self-sustained, I am working device diagnostics. Always it is available on the device, which give you the healthiness of the switch. We have the feedback in case we want to use as a feedback that if I am not working, that can be set according to the requirement. Field programmability, you can change the set point from the field itself in the field without any pressure pump. Switch with transmitter, it has a 4 to 20 milliamps output if you want to connect it to for the trending or any other application, and highly reliable. SIL 2 suitable device, it has been now, they had come out with the certification, and enhanced version SIL 2 and SIL 3 also has been certified. There is no heart output, that is what it is. Best practices, we need to consider what are the alternate solutions for a particular type of application. Upgrading safety interlock with a digital switch is an ideal thing, no need of any modification in the existing system. Analyze alternatives regarding the best combination of system reliability, performance and the total cost of ownership, including installation, commissioning, operation, maintenance, whatever. Consider the benefits of digital switching technology in upgrades new projects that we want to go ahead with that. Fast response, already SIL certification is there. Transmitter and switch outputs, obsolescence proof investment, that is a great thing, and cyber attack safe. Thank you very much.